On the day of the STAAR test, you guys are going to get one of these middle school science STAAR reference materials sheets. On the front side is the periodic table of elements. On the back side are a couple of formulas. But there's a lot of empty space around here that we're going to use to our advantage to hack the STAAR. So we're going to start with our chemical symbol box. We're going to mark out the word symbol, and right there we're going to write the word element. That's going to remind us that elements are the capital letter and lowercase letter in some cases on any of these. So if it asks how many elements there are or what are the elements in, we'll be able to find those elements. All right, now we're going to draw a line underneath hydrogen because it is not part of the group that we're about to identify. We're going to turn our paper to the side and we're going to write the word metals. So on the left side of the periodic table, you find your metals. Metals are luminous, which means they are shiny. They are good conductors, which means energy passes through them easily. They are malleable, which means they can be hammered into sheets. And I use mallet to help me remember that. It's like a little hammer. And ductile, which means that they can be pulled into wire. Okay, then we're going to turn our paper all the way back around. And on the right side, we're going to write non-metals. So on the right side of the periodic table, you find your non-metals. And their properties are that they are dull, so they are not shiny at all. They are good insulators, which means energy doesn't pass through them very easily. That makes them bad conductors. And they are brittle, which means that they break easily. Now we're going to write our paper, and we're going to use this staircase for our metalloids. Metalloids start with boron. Boron lives at the top of the stairs. We're going to go down to silicon, arsenic, tellurium, down through polonium, up through antimony, germanium, back to silicon and boron. Metalloids have shared properties. That means that they have some of the properties of metals and some of the properties of nonmetals. Then at the top of my page, right here in this blank space, I'm going to write my evidence of chemical reactions or chemical changes. So I'm going to write chemical reaction evidence. The first piece of evidence is unexpected color change. So that's when you're pouring two clear chemicals together and it turns blue. That's an unexpected color change. Next, we have an unexpected temperature change. Unexpected temperature change is like when we were doing the balloon with the baking soda and the vinegar and it turned cold. That's an unexpected temperature change. Next, we have that a precipitate formed. That's when you're pouring two liquids together or combining two liquids and it makes a solid in the bottom. So I'm going to write solid right here to help remind me that that's what precipitate means. Then right here above this STAAR logo, I'm going to write bubbles or fizzing, but that does not include boiling. So I'm going to write not boiling. Boiling is just a change in state. And finally, smoke, fire, or burning. Okay, if we have a chemical reaction, then we've got to follow the law of conservation of mass. So right here in this space, I'm going to write law of conservation of mass. And that's the one that says that energy cannot be created or destroyed. Okay, so I'm going to write reactant, yields, that's what the arrow means, product. And if I have whatever I have going in, so if I have 56.5 grams of something going into a reaction, then when I'm finished with the reaction, I have to have 56.5 grams of something else. Now down in this bottom corner, right here, we are going to write the chemical formula for glucose, which is C6H12O6. And I'm going to write a 1 right here for my molecules. Okay, if I look, I can see that I have carbon, hydrogen, and oxygen. That's 3 elements. I have 1 molecule. Remember, if there's nothing there, that's what that means. And I have 6 carbons, 12 hydrogens, and 6 oxygens. So I'm going to add up my subscripts, and 6 plus 12 plus 6 is 24 atoms. And then over here, to help me remember how to do the math, I'm going to write molecule multiply, because you're going to multiply all of your atoms by your molecule. And I'm going to write subscripts add. So you add up your subscripts. So add up your subscripts, multiply by your molecule. That's how you know what your total is. All right, now we are going to turn our paper over. And on the back side of our paper, we're going to start with a formula triangle. This one is for our speed formula. So we're going to write speed equals distance divided by time. When they're next to each other, we multiply. When they're on top of each other, we divide. So now I know if I need to find speed, I can cover this up. It's distance divided by time. If I need to find time, I cover this up. Distance divided by speed. And if I need to find distance, speed times time. Now when we've got our graphs, if we've got a distance time graph, so I'm going to label that. If I have a distance time graph, draw a picture of a graph on here for us. I'm going to go constant, stop, and then go constant again. So I'm going to label those pieces. This is a constant speed. And this is a stop on a distance time graph. Now, if this is speed, that means that's a constant. And then our other distance time graph that we want to make sure we have, and we're going to write distance, and we're going to write time, and we're going to draw a curved line, and that is acceleration. Okay, then we've got our formula for net force. So net force equals mass times acceleration. They've already broken down force equals mass times acceleration, and acceleration equals force divided by mass. So we just need our mass formula just in case. So mass equals force divided by acceleration. We're just going to add that to us, so no matter what they give us, we know how to use it. Now, if they don't give us net force, or we've got to calculate net force, we're going to use our diagrams. So they will give you a diagram, or they will give you the forces. Okay, so if I have 6 newtons to the right and 2 newtons to the left, I'm going to subtract that. So if they're opposite, you subtract. If I have my box and it's 6 newtons to the right and 2 newtons to the right, I'm going to add those. And when the forces are 0, that means they are balanced. And that either means that it is not moving, so it's at rest, or it's at a constant motion with no change. Now we're going to divide our paper, so I'm going to draw a line, and I'm going to divide my paper into 6 boxes. We'll start with seasons. All right, so for seasons, we're going to draw a sun in the center, and we're going to draw 4 earths. We're going to put an equator on our earths, and we're going to put the tilt on our earths, because that's what causes the seasons anyway. All right, we're going to make this our northern hemisphere. The northern hemisphere is where we live in the United States. And we're going to label our seasons. So when the northern hemisphere is tilted toward the sun, we're in summer. When the northern hemisphere is tilted away from the sun, we're in winter. Between winter and summer is spring. And between summer and winter is fall or autumn. In the summer, we have longer days, which means we get more daylight. And we have shorter nights, which means we get less time without the sunlight. And in the winter, we have shorter days, so we have shorter sunlight. And we have longer nights. And then the southern hemisphere, so Australia, Argentina, the southern hemisphere is opposite. Now in the second box, we're going to write a tides diagram. All right, so you'll have your sun here. Then in the middle, we're going to put an earth. And we're going to put 4 moons around the earth for different positions. When the sun and the earth are in a straight line, that either happens at a new moon or a full moon. And that is called a spring tide. And that's when we have the highest high tides and lowest low tides. There's a great difference between the different tides. And we can remember that because spring equals straight. They're in a straight line. Okay, now when they're at a right angle to each other, That either happens at a first quarter moon or a third quarter moon. And that is called a neap tide. And we can remember that because neap is 90, so 90 degrees. We're going to draw a little arrow to our right angle there. And that's when we have a minimum difference, so not a lot of difference between high tide and low tide. All right. Okay, moving to our third box, we're going to put plate boundaries in here. So when the two plates are headed toward each other, we call that convergent, because they are converging, they are running into each other. And that creates folded mountains. When they run into each other and one oceanic crust slips underneath a continental crust, we call that subduction. And that creates trenches and volcanoes. When the two plates are moving apart from each other, that is a divergent plate. They are dividing, they're moving apart, they're separating. And that creates rift valleys for continental crust and mid-ocean ridges underwater. And then when the two plates are sliding past each other, we call that transform boundaries. And that's when we get earthquakes. Now in our fourth box, we're going to put some vocabulary that's going to help us with some of the biology questions. So we've got biotic. Biotic means living or once living. I like to think about zombies to help me remember that anything that was ever alive is biotic. So zombies are biotic. For abiotic, that means non-living or was never living. Those are things like rocks, water, air. Then we have prokaryotic. So a prokaryotic cell has no nucleus. And we can remember that because pro and no. A eukaryotic cell has a nucleus. And you have a nucleus. The nucleus stores chromosomes. And genes. That's where the genetic material for the cell is. And then our last two words, autotroph. That is an organism that creates its own food. That doesn't mean they make it in a kitchen. And a heterotroph hunts for food. And we can remember that because heterotroph and hunt both start with an H. Okay, moving on to box number 5. We are almost done. We have weather. So we're going to draw a cold front. Make sure your triangles are pointy so that you don't get them confused. I'll label that cold. Then we'll have our warm front. Remember that one's got the little semicircles, and make sure they look like semicircles. And that is a warm front. And then a big H for high pressure. Remember, that's happy weather. So it's calm and cool. And then L is for low pressure, and that's lousy weather. So that is warmer, and that is rainy. Doesn't mean it's going to be hot in the middle of February, but it does mean that it's warmer than it normally would be without it. Then we've got hurricanes. So hurricanes are typhoons, are tropical cyclones. Remember, they're all the same kind of storm. It just depends where on the earth you are, what you call it. And to have one of these storms, you need warm, humid air. You need warm ocean water. And you need low pressure. And cold water or land will destroy them. And our final box is our cells box. We're going to do a plant cell versus an animal cell. In a plant cell, you'll find a cell wall. Remember, they need those for the structure and support. You'll find chloroplasts because they make their own food. You'll find a larger vacuole because they store a lot of water. And plant cells are usually square or rectangle shaped. Then an animal cell is going to have a smaller vacuole. And it's going to be rounded. Then our very final thing we're going to do is draw this little kind of roller coaster hill, and we're going to label it for potential energy. The most is at the top of the hill just before you go down. We're going to label that potential. That's stored energy. And kinetic energy, you're going to have the most at the bottom of the hill. And kinetic energy is energy that is in motion. Energy that's moving. All right, so if you get all of this on your paper and you're able to remember all of this and you're able to use this on your test to help you, you should have a great setup for our STAAR test. Good luck.